So this time we're going to be writing some algebraic rules. You probably remembered last time we were finding a rate of change given a table or given a sequence. So here's an example. This tells me that there's a relationship between x and y. When x is equal to 1, y is 3. When x is 2, y is 7, and so on. And one thing I notice about this is I want to figure out the rate of change, which means what's the y value doing every time the x value increases. So if I look at this, it looks like the y value goes from 3 to 7, the y value goes up 4. Every time the x value goes up 1. Does that pattern keep true? Well, from 7 to 11 is 4. 11 to 15 is 4. That's great. So we're following that constant pattern. And as I can see in my x's, each time that my x increases, it goes up by 1 as well. So now looking at this, I know that my rate of change is going to be that the y values change by 4 as the x values change by 1. So the change in y over change in x, remember we call that the slope. Our rate of change is 4. So that's what we did last time. So how are we going to extend it this time? Well, we want to know what would the y value be when the x value is 0. Because what we saw before was that every time the x value increased, the y value increased by 4. So what I'm wondering is, let's go back 1. If I go back 1, I get to x being 0. So this time, my y values, instead of going up by 4, what I want to do is I want to go backwards. So I want to go down 4. And 3 subtract 4 is negative 1. So the y value when x equals 0 is at y equals negative 1. So that's pretty helpful. Do you know what you might want to call that value? I don't know if you've heard of that value before, the y value when x equals 0. We've called that the y-intercept. Sometimes it's called the starting value. So those are some words that we'll use, this y-intercept, the starting value. So now we have enough information where we can write an equation that represents the rule. We can relate y to x using an equation. So here's how we'll do that. So we'll say that the y value is equal to something that we do to the x. Well, if you notice, the rate of change said that every time x went up by 1, the y value went up by 4. That was when we said that our rate was 4. So I'm going to write 4 times x. Because since the x value increases 4, the y value increases 4 each time, another way to represent multiple forms of addition is to multiply it. So multiplication is really repeated addition. We're adding 4 each time, so we get 4 times the x value. But we also have a starting value. And we find our starting value by finding the y value when x equals 0. We worked backwards and found it to be negative 1. So that rule, y equals 4x minus 1, will determine y when you're given an x value. Let me show you what I mean. Let's pick an x value from our table. Maybe we'll pick x equals 3. If I plug 3 in for the x, what I get then is y equals 4, not times x, but multiplied by 3. Subtract 1. 4 times 3 is 12. 12 minus 1 is 11. And sure enough, that matches up with my table because my table shows the point 311 in it. Very nice. Well, let's keep going. It's going to be your turn to play now. What I'd like you to do with each table is first find the rate of change, find the y value when x equals 0, the y-intercept, and then write me the rule that relates y to x. So if I'm looking for my rate of change, what I notice is that every time x goes up by 1, it looks like my y value goes up by 6. And the same holds true with my x again. If I go up 1, it looks like I'm going up by 6. So that rate of change is 6. So I'm going to start by saying y equals 6x. And then I got to fill in that y-intercept. Well, let's go backwards now. if I'm going backwards, let me subtract 1 to get to 0. So I'll subtract another 6 in this case. Negative 7 subtract 6 is negative 13. So my starting value is negative 13. So y equals 6x minus 13 is my rule. Hey, did you notice something about this second one? It looks like now my x value does not go up by 1. My x value is going up by 2. Okay, not a problem. Not a problem. Let's see what the y values are doing. It looks like the y values are going down by 4. So that's going to tell me that my rate of change is what my y values are doing as my x values change. So that's my slope, the change in the y divided by the change in the x. And that's going to equal negative 2. So knowing that my rate of change is negative 2, I can write my equation as y equals negative 2x. Now again, let's go back and find that y-intercept. Instead of going up by 2, I'll go down 2. So instead of going down 4, I'll go up 4. And I'll get 13. So when the x value is 0, the y value is positive 13. So there's my rule, y equals negative 2x plus 13. As you can see in your notes, we're not only doing this with a table and with numbers, we can actually do it with a pattern as well. So we want to determine an equation now for the number of squares in the nth figure. So let's talk about what that means, first of all. N is a variable that's going to represent whatever figure number we have. So let's say that this is figure number 1, and this is figure number 2, and this is figure number 3, and this is figure number 4. So then the nth figure would be any other figure that we might want to create. If n equals 5, it's the 5th figure. If n equals 10, it's the 10th figure. So you can probably see if we want to figure out how many squares are in the 10th figure, we don't really want to have to draw the 5th, 6th, 7th, 8th, 9th, and 10th figure. We want a rule to give us that. So what I notice here is that in the first figure, when n equals 1, there's 1 square. When n equals 2, it looks like there are 5 squares. When n equals 3, there's a total of 9 squares. When n equals 4, there's 13 squares. So notice that I actually took this pattern and I created a list of numbers, an input and an output. My input is what number figure am I on? My output is how many squares does that figure have? So let's see if we can determine the rule now. Why don't we say things like the number of squares S, so we'll let S represent the number of squares in that nth figure. So instead of using like a y equals, let's use S equals. And let's figure out our rate. It looks like that each time to get to the new figure, we're adding 4 new squares. So our rate of change then is 4. So why don't we say that our figure, the equation then is S equals 4n. We'll let n be the number of the figure, the first figure, the 4th figure, the 10th figure. Well, remember now we have to figure out what that starting value is. And I know it doesn't really make too much sense here. But if I go back 1 to figure 0, following my pattern, I should subtract 4 to get negative 3. I agree with you. You can't draw negative 3 squares. But at least it gives us where we would maybe start. So we'll say that 4n minus 3 is our rule. Let's check that. Let's say we want to figure out how many squares are in the 4th figure. We know what the answer is based on our pattern before. But if n equals 4, let's just check it. S is going to be equal to 4 times n. 4 times 4 is 16 minus 3. S is 13. And sure enough, our 4th figure had 13 squares in it. So that rule, s equals 4n minus 3, determines the number of squares in the nth figure. Now, you're probably recognizing that these equations are in a special kind of a form. You might remember that form from earlier past. Let's see, if I drag out this triangle, I get my information. These are of the form y equals mx plus b. I'm sure you've heard of that. I see you nodding your head right now going, yeah, I've heard of that. M is the slope. M is the rate of change. B is our y-intercept. It's the output when the input equals 0. And one thing I should add to this, I guess, is that the number that we put in for our input is our x variable, our independent variable. And that the output is our y value. The output is our dependent variable. So I'm sure this is something you've probably been familiar with, y equals mx plus b. So at this point, you should be able to write an equation using y equals mx plus b to represent a situation. Great job today.